In this video, we're going to try to compute the following limit of an, given that an is given by the product of 1 plus k over n, everything to the power 1 over n. Okay, this product is going from 0 to n minus 1. The first thing that we need to notice is that 1 plus k over n is positive, and therefore 1 over n when we raise it to the power of n, it's going to be positive. Okay, so the key idea here is that this problem can be solved if we can transform this product here into some sum, and we can do that by just taking the natural log of an. Okay, when we do that, we're gonna have the sum. Okay, we know that these sums are positive, therefore we can apply the rule. The natural log of a times b is that the natural log of a plus the natural log of b. Okay, so here we can have this sum, okay, going from 0 to n minus 1 of the natural log of 1 plus k over n to the power 1 over n. So we'll take this one to the front. Okay, so it's gonna be 1 over n, the sum, okay, from 0 to n minus 1, the natural log of 1 plus k over n. Okay, now if we see that the natural log is continuous. Okay, so if we think of this one as some Riemann sum, and we think of this one as delta x, okay, because we know that the integral of f of x dx between a and b is the sum, or the limit before the sum, of b minus a over n, that's our delta x, the sum of k from 0 to n or n minus 1 of f of xk, with the xk's are carefully chosen, the simple ones. So we can see that if we think of b as 1 and a of 0 as 0, we're gonna have the integral of this function that we're gonna have to see that it's the, if we think of the xk's as k over n, okay, because a is 0 and b is 1. Okay, so here we see that we can take the limit. Okay, we can take it inside because the natural log is continuous. Okay, so we're gonna have the limit inside. So we're gonna see that we have the natural log of the limit of not an in this case, because an is in this form. So that's why we're gonna switch it. Okay, so here we have the log of the an. So when we do that, we're gonna have the limit as n goes to infinity of let's say 1 over n, the sum k from 0 to n minus 1 of ln of 1 plus k over n. If we think of this one as x, okay, so we're gonna have this one as the integral between 0 and 1 of ln of 1 plus x dx. Okay, and we can use some integration by part, okay, to see that we can put a 1 here, okay, and we can therefore use the fact that this one can give us ln x ln of 1 plus x minus 0 1 x over 1 plus x dx. Okay, here I need to evaluate between 0 and 1. So I have 1, the natural log of 2, when x is 0, we have 0, minus the integral between 0 and 1 of x plus 1 over x dx. So the issue is here. We need to evaluate this one. To do that, let's see that we can add and subtract 1. So here, if we add and subtract 1, we get the integral of 1 minus 1 plus x dx. This one is going to give me x, so that means when I integrate, I get to 1, and this one is going to give me the natural log of 1 plus x between 0 and 1. Therefore, I have 1 minus the natural log of 2. Okay, so therefore when I evaluate, I get the natural log of 2 minus 1 plus the natural log of 2. When I do that, I have 2 the natural log of 2. That means the natural log of 4 minus 1. So this one I can write it as e. So it's going to be the natural log of 4 over a. And when I took the log, so I can take the exponential to get back to my limit. Okay, so my limit, so I take the exponential back, so I'm gonna get 4 over a. This means that this limit of an as n goes to infinity is just 4 over a. And I think that's all we need for this kind of problem. Thank you.